Okay, question 27 says two samples of water of equal mass are heated to 60 degrees Celsius. One sample is poured into an insulated container and the other sample is poured into a non-insulated container. So we have the two types of containers. The samples are then left for 70 minutes to cool in a room having a temperature of 25 degrees Celsius. The graph above shows the temperature of each sample at 10-minute intervals. Which of the following statements correctly compares the average rates at which the temperatures of the two samples change? Okay, so what we have is the insulated container in the square markers, and then the non-insulated in those circle markers. And you can see the non-insulated loses temperature very quickly and is trying to get to the room temperature of 25. And this insulated one loses its temperature. The temperature drops a little bit slower than the other one. Okay, because it's insulated. So let's take a look. In every 10-minute interval, the magnitude of the rate of change of temperature of the insulated is greater than that of the non-insulated. So the insulated one, you can see for the first 10 minutes, the non-insulated dropped way more than the insulated. So this is false right off the bat because they're saying that the insulated one dropped more. Magnitude of the rate of change, they just mean look at the steepness. Don't look at the fact that it's a negative slope. Just look at how steep it is. They're saying that for the insulated sample, these square markers, it's steeper, but it's not steeper. They're saying it's steeper all the time, and that's not true. So A is out. For B, in every 10-minute interval, the magnitude of the rate of change of temperature of the non-insulated is greater. So they're saying that these circle markers is always steeper every 10-minute interval. Now, it is true that it's steeper for the first 10-minute interval. You can see it's steeper there compared to there. But is it true always? Well, let's look over here. You can see over here that the circles is not that steep, but the squares is steeper. The squares are dropping more than the circles. So that's one example where the circles is not steeper. And here you can see circle to circle is almost level, but the square is dropping. So you wouldn't say that this is steeper. So B is out. In truth, they the steepness starts. The circles start out steeper, but level off quicker. Okay, so now option C. In the intervals from 0 to 10 minutes and from 10 to 20, so the first 20 minutes, the rates of change of temperature of the insulated sample are of greater magnitude. So the insulated is steeper, they're saying, for the first 20 minutes. But the insulated is not as steep. You can see this is less steep than that. So C is out, which leaves option D, which has to be correct. But let's take a look. Let me clear this out real quick. So let's look at option D. In the intervals from 0 to 10 minutes and from 10 to 20 minutes, so the first 20 minutes, the rates of change of temperature of the non-insulated sample, which is the circle marker, are of greater magnitude. So they're saying the circle is steeper for the first 20 minutes. So that's steeper than that. That's true. That's deeper than that. That's true. And then they say, whereas in the intervals from 40 to 50 and 50 to 60, so this 20-minute period, the rates of change of temperature of the insulated sample are of greater magnitude. And that's when they say the square is dropping faster. So if you look at the square, it's dropping faster than the circle. The circles are pretty much leveling off, and the squares are dropping faster than the circle. So that part is also true, so the answer is D.